All right, so I've done a video where we were pulling marbles out of a bag and then we're putting them back in. Now we're going to do this when we don't put the marble back in. So we're going to do the probability. This is going to be without replacement. So I have my same setup. I have my 10 marbles in here. So I have 10 marbles. I have 3 white. And I have 7 cat eye. So I have 3 white and 7 cat eye marbles. All right, from here, we're going to do the same thing that we did with the last video where they're independent. But here we're going to have some sort of dependency because the second branch of our tree is actually going to change. So we're going to do a tree diagram. I'm going to start out with all 10 marbles in my bag. With all 10 marbles in my bag, I can still only have 2 outcomes. The 2 outcomes are going to be a white marble or a cat eye marble. So I'm going to draw that out, white and cat eye. So white, cat eye. But this time I'm not going to put it back in. I'm going to pull another marble out. And my outcomes are still white, cat eye, white, cat eye. All right. Now, just like before, we're going to look at this first branch. And we're going to say, we got 10 marbles. There's 3 white, so I have a 3 out of 10 chance of pulling this out. So it's 3 out of 10. Now on this branch, I have now pulled 1 white marble out. So I don't put it back in. So now I only have 2 marbles left out of 9. So to pull another white marble out, I want to have 2 out of 9. So your numerator and denominator are going to decrease by 1. Now here with my cat eye, all my cat eyes are still in there. So I don't decrease my numerator by 1, but I'm going to decrease my denominator because even though there's only 9 marbles in there because I pulled a white marble out. So this is going to be 7 out of 9. Now down here, starting from scratch, my cat eye marble, I have 7 out of 10. Now here on my branch for white, I still have all 3 white marbles in there, but now there's only 9. So I have a 3 out of 9 chance of pulling it out. You can reduce the fraction. I don't really care. And then, of course, here on the cat eye, you have to be careful. You're already missing 1 cat eye and you're missing 1 marble. So you have to subtract 1 from your numerator and your denominator. So the chance of pulling another cat eye out is going to be 6 out of 9. Of course, you can reduce your fraction if you want. The process is going to be the same. We're going to multiply the legs to actually see what's going to happen. So my probability of pulling a white marble out after I pulled a white marble out is going to be 3/10 times 2 9s. When I do that, I am going to get, this is 6 over 90. And the 6 over 90, this is approximately 4.4% of the time. Okay. Now the probability of pulling a cat eye out after I pull a white marble out, well, I'm going to multiply my legs. 3 over 10 times 7 over 9. This gives me 21 over 90. And the 21 over 90 is going to be approximately 23.3% of the time. And you're going to repeat the process for each leg. So this leg, so we have my 4.4%, that's right here, 4.4%, that's right there. This leg here is 23.3%. This percent here is also 23.3%. And to pull a cat eye and a cat eye out, we're looking at 46.6 or 46.7%. Now these percents are rounded. In the perfect world, they add up to be a perfect 100%. But when I actually worked this out, I looked at my fractions here and here. I had 6 over 90, 21 over 90, 21 over 90, and then 42 over 90. And when I add all those up, I get 90 over 90, which is that magical number 1 that we're always going to want with probability to have everything accounted for. So this is my experimental probability. 4%, 23.3, 23.3, 46.7. So let's do our experiment. Now this time I'm not going to put the marble back in. I'm just going to pull it out. Cat eye, cat eye. All right, so here we have 10 trials. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And then from here, we can calculate my experimental probability. So let's do the probability of a cat eye and a cat eye. So I have 1, 2, 3, 4, 5, 6, 7. So I had 7 out of 10, which is just simply 70% of the time. That is way off of my experimental probability. The next thing I can do, let's see, I have the probability of pulling a cat eye after I pulled a white. So I pulled a white, then a cat eye, it's right here. So I had 1 out of 10, which is just simply 10%. Way off of my probability again. The probability of pulling a white after I pulled a cat eye. So here's a white or a cat eye and then a white, cat eye and a white. I have 2 out of 10, which is 20%. And of course, the probability of getting white after pulling a white, that was 0 out of 10, which gives me 0%. Okay, here's what's great. On the last video, I was fairly close. On this video, my experimental probability really differs from my experimental probability. Because here I got cat eye was 7 out of 10, but theoretically I should have only gotten 5 out of 10 roughly, because of 46.7%. Now, I would not expect to have a white and a white because it's only 4.4% of the time. So it's a pretty low likelihood of actually getting it. So this one doesn't surprise me. And white and cat eye doesn't surprise me. But here, these two are quite a bit different than the the theoretical probability. Hi, I'm Mr. Buzzard, and I'm making these videos as supplemental instruction for my students. If you found these videos actually informative or they answer the question you're looking for, make sure you hit the like button and then don't forget to subscribe and then click the bell to receive notifications for future instructional math videos.